In this video, we will talk about how to convert binary to hexadecimal. So in a base 10 number system, or sometimes just called a decimal system, the values start at 0, then they go to 1, then 2, and they're just a bunch of numbers. But in a base 16 system, or sometimes called a hexadecimal system, we start at 0 and we go up to 9, but once we reach 10, we use an A to represent 10. And we use a B to represent 11, C represents 12, D represents 13, E represents 14, and F represents 15. So if we want to convert binary to hexadecimal, how can we do that knowing this? Well, the first step is we have to, starting from the right, find groups of 4. So we'll say, here's a group of 4, and here's a group of 4. And the reason that we do that is because this first value right here is going to correspond to 2 to the 0 power in a binary system. The second value will be 2 to the first. This third value will be 2 to the second. And this fourth value will be 2 to the third. So what are these values? Well, 2 to the 0 power, anything to the 0 power is 1. 2 to the first is just 2. 2 squared is 4. And 2 to the third, or 2 cubed, is 8. And using these 8, 4, 2, and 1 values, we can make any value from 0 to 16 in the hexadecimal system. So I'm going to erase this and just write 8, 4, 2, 1. So 8, 4, 2, and 1. Now, if a binary value has a 1, then we're going to underline the corresponding value. So notice that the 4 also has a 1, so we'll underline that. And the trick is we just add the values that we underline. So 4 plus 1, this whole thing just becomes a 5. So that's what 0, 1, 0, 1 represents in a binary system. It represents 5. All right, what about this next chunk of 4? Well, let's write 8, 4, 2, and 1. So this 1 will be underlined. This 2 right here, it has a 1, so we'll underline it. The 4 has a 0, so we're not going to underline it. And the 8 has a 1, so we will underline it. And then we'll do the same thing. We'll just add all of these values together. So 8 plus 2 plus 1 is 11. But remember, in a hexadecimal system, 11 is actually represented by B. So we'll write a B right here. So our final answer is just going to be these two values put together. So B, 5. So the binary number 10110101 corresponds to B5 in the hexadecimal system. All right, let's try another example. How can we convert this binary number to a hexadecimal number? Well, remember again, we're going to start from the right and we're going to identify groups of 4. So here's a group of 4, here's a group of 4, and here's a group of 4. And we'll use the same process that we did in the last example where we say 8, 4, 2, and 1. If there's a 1 right here, we're going to underline the corresponding value down here. So here's a 1, here's a 1. Notice that the 8 has a 0, so we don't need to underline the 8. So this value will be 4 plus 2 plus 1. That's 7. So this portion right here is just equal to 7. All right, what about the next one? Let's do 8, 4, 2, and 1. So this has a 1, this has a 1, and the 8 has a 1. The 4 has a 0, so we don't need to underline it. So let's see what the sum of these values are. 8 plus 2 plus 1, that's 11. And remember, in a hexadecimal system, 11 is represented by B. So we'll write B. And then for this last group, we'll write 8, 4, 2, 1. So this has a 1, and the 4 has a 1. So the sum of these values is 4 plus 1, which is 5. So our final answer is 5B7. This is the hexadecimal representation of this binary number. All right, let's try another example. How can we convert this binary number to a hexadecimal? Well, again, starting from the right, we will identify groups of 4. So here's a group of 4, here's a group of 4, here's a group, and here's another group. And we'll repeat the process where we write 8, 4, 2, and 1. And we'll just underline the values that have a corresponding 1. So it's only the 4 in this case. So this whole number is just a 4. All right, what about this one? 8, 4, 2, and 1. Well, notice they all have 1s, so we're going to underline every single value. So our sum of values will be 8 plus 4, which is 12, plus 2 is 14, plus 1 is 15. In the hexadecimal system, F represents 15. So this will become an F. All right, what about this group of 4? 8, 4, 2, and 1. We'll underline the 1 and we'll underline the 8. 8 plus 1 is 9. And for this last one, we have 8, 4, 2, and 1. We'll underline the 8 and underline the 4. So 8 plus 4 is 12. In the hexadecimal system, C represents 12. So this whole thing becomes a C. So our final answer is these values put together. So C9F4. All right, let's try one last example. How can we convert this binary to hexadecimal? Well, starting from the right, we'll form groups of 4. So here's our first group of 4. Now notice we don't have enough values to form a 4. So what we'll say is we'll just add in zeros, as many zeros as we need to form a group of 4. So here's our next group of 4. Okay, so the last step is we'll write our 8, 4, 2, and 1, and we'll underline the values that have a 1 that correspond to them. So it's only the 2 in this first group of 4. So this whole thing is just a 2. And in this next group, we have 8, 4, 2, 1. It looks like the 1 and the 2 will be underlined. So 2 plus 1 is 3. So our final answer is 3, 2. This is the hexadecimal equivalent of this binary value.